See how far we can get with this one. Use the fundamental identities to find an equivalent expression involving only sines and cosines. Okay, we got to remember all of our conversions and then simplify. So remember your reciprocal identities as well as your quotient identities. Very, very, very important. Looks like reciprocals are coming into play. Secant is the same thing as 1 over cosine, and cosecant is the same thing as 1 over sine. You can't change the operation. The plus sign has to remain. Now, for you to add fractions from way back when you were in elementary, you've got to have a common denominator. So cosine, sine. Remember, we always structure these as numerator times what's different, and numerator and what's different. Sometimes I call them leftovers. So if you will look and see, compare this denominator to this denominator, how's it different? Well, this one has a sign, so that goes up there. Now compare this one to this one. Well, it's different. This one has a cosine. That's going to let you figure out what your new numerator is going to be. So 1 times those don't really change. It's just going to be sine of theta plus cosine of theta all over cosine theta, sine theta. And other than going around in circles, I'm not quite sure what else we can do with that. Let's see how they left it. That's it. That's exactly what they wanted us to do with it. That's as good as it gets. So you don't always go smaller. That thing got a lot bigger. Okay, I'm going to get my pen a little larger. Use the fundamental identities to simplify the expression. Okay, I see squares, so that should remind you of your Pythagorean identities. We have sine squared right here. We have cosine squared there. They do something special. Remember, they add to 1. Nobody said they had to be sitting side by side. They just both need to be positive. This is a positive sine squared. That is a positive cosine squared. You can take both of those, replace them with a 1. This other item, this other term, just needs to drop down. Well, lo and behold, what do you know about 1 plus tangent squared? That looks like another identity. 1 plus tangent squared, you can swap him out for secant squared. And I do believe that is as good as we're going to get. Okay, verify that each equation is an identity. These are so much simpler because you don't have to wonder where to stop. Okay, we're going to work with the left and turn it into the right. Let's go ahead and distribute the tangent. So that's going to give me tangent of x times cosecant of x minus tangent of x sine of x. Now, it depends on, how many steps you want to skip. Personally, I would have changed those to sines and cosines at the same, in that line right there where I distributed, but I didn't want to lose anybody. So we're going to break it into 2 steps. Tangent is sine over cosine, and cosecant is 1 over sine. Oh, that looks interesting. And then we've got sine over cosine over here. And then remember, we're just going to turn everybody into fraction form so we can see what we've got to work with, okay? You need to see what can reduce and what does not. Okay, when you evaluate this first section, which is a whole term, remember terms are separated with positives and negatives. In this term, you've got a sign in the top, a sign at the bottom. They reduce. They don't go to 0, they go to 1. So what's left is a 1 in the top and a cosine in the bottom. Okay, I'm going to bring down that minus sign. And over here, nothing reduces. But we are left with a sine squared. Sine times sine in the top and a cosine in the bottom. Well, isn't that lovely? Look at your denominators. They're already the same, which means you can just squish your 2 little fractions together. You don't even have to worry about making a common denominator. The numerators stay the same. You're just kind of pushing them together and making one great big one. Okay, now I'm going to go ahead and write this because I'm fixing to have to scroll. I want to make sure we have what we need. This should make you think of your lovely little Pythagorean identity, sine squared plus cosine squared equals 1. Remember, you can rearrange it. If you move the sine squared over, that's going to be cosine squared equals 1 minus sine squared. You can swap them out. So if you got 1 minus sine squared, switch it. That's cosine squared. Oops, I should be an x, shouldn't I? Okay, over cosine. Now, you're sitting pretty at this point because you've got 2 cosines up there. Not with a 2 up there, but that's cosine times cosine up there. and a cosine in the bottom. So one of these reduces with that one down there. So you have one cosine left over. As a better explanation, think of it like this. You have cosine times cosine, and in the bottom you have cosine. So you can see that a pair will reduce, and you're left with that one, which is exactly what you need, okay? Okay, more identities. I still see a lot of squares. So when I look at this right here, I'm thinking, the only thing that just crosses my mind to start with is there's 8 here and there's 4 there. I wonder if I could factor out an 8, or factor out a 4, would that help me? So I'm going to take out a 4. That's going to leave me 2 cosecant squared minus cotangent squared. Okay, now, just to kind of keep an eye on what I'm doing, this side only has cosecants. There's no cotangents there. So let's see if we can make the cotangents go away. We need to switch and swap. Now, do you guys remember that 1 plus cotangent squared is equal to cosecant squared? Okay, so let's just think. If I can take cotangent and get him alone, that's going to be cosecant squared minus 1. All right, so hang on. We're going to use some creative grouping symbols here. We're not going to touch this first guy. And I may not have needed to pull that 4 out. You know what? May not have needed to do that, but let's just see what happens. I'm going to leave this minus. Now, instead of cotangent, I'm putting this right here, cosecant squared minus 1. But I need to put it in grouping symbols so that I don't lose a sign. That negative will eat my lunch if I don't wrap that up. Okay? So, when you go through here, I've got my little 4. I've got my 2 cosecant squared theta. That's going to be minus cosecant squared theta, but that's going to be plus 1. All right. These two guys go together because they're both cosecant squares, and I shouldn't have taken that 4 out. I should have just left it alone, but it's okay. I can distribute them in a minute. These two go together, cosecant squared theta, because 2 minus 1 gives you 1, plus 1. Okay, and then I'll put my 4 back in because I should have never taken him out, but you know, it didn't really hurt anything. And when you see something, just try it. Sometimes it'll work, sometimes it doesn't, but normally it just gets the ball rolling. And that's what you need to do with identities. Just give it a shot and roll with it. Okay, number 61. Oh my goodness, looks like the left side is a lot messier. The right side only has sines and cosines, but the left side has tangents and cotangents. Let's just go ahead and make it nasty. Tangent is sine over cosine, and cotangent is cosine over sine. Okay, same thing. Sine, cosine. Here's our difference. Now it's the difference. We're subtracting. I'm going to have to get a pen. I got the squeakies. Okay, now we definitely have a complex fraction. Now, to handle a complex fraction, remember we're going to multiply top and bottom by the common denominator of our little bitty fractions. Every little bitty fraction either has sine or cosine. So we're going to do, that did not show up, did it? Sine cosine over sine cosine. That is my common denominator of my little bitty fractions. So if I multiply, think of that over 1 and that over 1. Okay? When I distribute that times this huge fraction, all of my little complex stuff should go away. So let's just think. This piece times first baby fraction. The cosines would go away because I got a cosine in top, a cosine in bottom. They reduce. Boom. That leaves sine times sine, which is sine squared. Now proceed to the next fraction. I have a sine in the top and sine in the bottom. They reduce. Cosine times cosine is cosine squared. All right, everything's good. Go down and repeat. It's going to be the same thing, right? We're going to have sine squared. The only difference is this is minus cosine squared. Now one of those is special. Hopefully it's dawning on you that the first one, the top one, is 1. The bottom one, not so much. You can't do that with a minus sign. But lo and behold, what did we want? Exactly what we got. So it's not that bad. Y'all can do this. Okay. Whew. Same thing. We got more fractions going on. Sounds like y'all need to get your fraction groove going. That little minus sign right there tells us we need to put these together because whenever you look over here on the right side, there's one term. Everything's multiplied over here. On the left side, we have two terms. We have fraction minus fraction. Now, personally, this is just me being weird. My handwriting's bad enough. Me doing T's like that is going to be pretty hurt, so I'm going to swap to X's. Common denominator, 1 minus cosine X and 1 plus cosine of X. All right, so remember what we said earlier. That means our current numerator is going to be multiplied by what's different. We're going to bring the sign right in there. Be careful with that. That could make a hot mess if you're not careful. Oops, not cotangent, it's cosine. That T just throws me all out of whack. And then whatever's different. Okay, so now let's evaluate. How is it different? Check out this first denominator comparing to our common denominator. The minuses are the same, but I don't have one of these plus, one of these sums. All right, compare the second. You have the sum, but you don't have the difference. Okay, so yeesh, you've got a mess. But that's okay. You can distribute, and hopefully it dawns on you that these are, you got conjugates in the bottom. The conjugates in the bottom are super easy because that's going to be 1 minus cosine squared x. You can go back and multiply it out if you need to. But here we just have a binomial squared, right? So we're going to square the first, twice the product, and square the last. Cosine x squared. Now please, 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 please be careful on the back end because this thing is like a little nuclear bomb that's going to go off if you're not paying attention. You need to block this product off. Go ahead and work it out like normal and then distribute your negative. So that's going to be, it's still the binomial squared. Square the first, twice the product, it will be negative, and then square the last, which will always be positive. Okay? Now, let's do a little bit of distributing. I got 1 plus 2 cosine x plus cosine squared x minus 1 plus 2 cosine x minus cosine squared x all over this lovely little denominator. Okay, now I'm going to go ahead and copy this because we're going to have to scroll, and remember I'm changing to x's. Okay, so let's get some space. We're going to have to expedite this problem. Let's get our like terms together for one thing. 1 and negative 1 cancel. I have a 2 cosine here and a positive 2 cosine there for 4 cosines. So those are taken care of. And I have a positive cosine squared and a negative cosine squared. Wow, did that shrink. All right, now here's the thing. I need to get to one item, one term. 1 minus cosine squared. Hopefully that rings a bell that is sine squared. Now what we can do, because you see there's 2 trig functions over here, if it's not clicking in your brain yet, what we're going to do is we're going to leave cosine up there. I'm going to separate sines. Okay? Think of it like that. Now, you should be able to see it. I was hoping that that would move, and it's not going. So we got the 4, and then cosine over sine is cotangent. And 1 over sine, see if you bust it up like that, 1 over sine is cosecant. Okay, and we did just wind it up. Perfect timing. We've got it. Spot on. There you go. You guys can do this. You just got to persevere.